So just show you this is the filament grip sort of side, and it's what I'm calling a groove bearing. Now when they say groove bearings, quite often they mean the groove inside for the balls to run against. But this has balls, some people call these U bearings or V bearings. Now there are different sizes of grooves in these. You don't want one too big. So that's to help as the filament's going through. Keep that in line. Okay, I've got, this is the only 8mm bolt I had that was anywhere near the size, so that's what I'm using. That's going on the reverse side. So this is the encoder wheel. See, that has just a normal optical endstop thing on there, and that sends a signal over. When that stops, then it knows it's either the filament's jammed or run out, and that will signal in sort of replacement. See, the filament runs across. This is like off a dual gear, but I don't think it really matters so long as you've got a bit of a groove in there and anything for the filament to grip on. When that idler wheel presses on there, it's going to turn the wheel. This is painted white on this side. I don't know. That's to help stop any infrared light coming through, because it can come through the plastic a bit. These have what I believe is a Schmidt trigger on, which even if voltage rises like that, it'll switch on and off, so it gets a defined sort of pulse. Nothing much I can say about it, works okay. Right, I'm just going to do a simulation here. I've got the temperature up, move it through there. Let's do 100, I think. Well, 110 there. You see, as the filament's feeding, it's getting a signal to pulse, and that's telling the firmware that there's filament in, there's no jam basically. Good solid pulse there with the white paint on. When I didn't have the white paint on, it was dimming a bit. This is in a way the new filament runout sensor. On the old one I had dual gears on, which I found that when the filament was pushed in, it was pushing the gears apart and the teeth were hardly touching each other, and I think there was more resistance on that. This one has like a skateboard bearing, that's what I'm trying to think of. Basically skateboard bearing, but it's got a groove in the outside. You can get them with grooves, I think they're called U bearings. Don't look for, well yeah, you can look for deep groove bearings, but when they say deep groove bearings, I think they mean for the ball races. But these actually have a bit of a groove in the outside for the filament to latch in. Now I know there are at least two different depths of those grooves. This is a shallow groove on this one. I don't know if we can see it at all in there. Just see the top of it. This is like on a spring thing, quite loose here. As you can probably see, I am about to run out of filament here. So it's got this encoder wheel here, Optical Endstop. This is painted white on the inside to reflect any infrared as it goes across. This seems to be going a lot better than the dual gear method I had. To be honest, you would think dual gear would be better. This is a dual gear feeding thing I've got here. It's got teeth on the top there. That's alright. I want to try and get this, hopefully get retractions, because I found retractions were being better on this. On the other one was bunching up and not pushing back because there was too much resistance in here. Now I am going to do a little bit more of a print of this, where this bolt that goes through here will be a bit high up, so that's a bit sort of more level, this top here. So as it's filament's feeding, it's signalling. Probably might see the light there, and it does have an LED on here. So I'm calling this a clever runout detection, because you can see that the filament is moving by the wheel turning or the light flashing. And that's sending a pulse over to Marlin, which you can set up all the settings in Marlin, which I use anyway. I don't know about other things like Brat or whatever it is, don't ask me. Well, I suppose you can do it in there as well. But you can change all the settings for how far it runs out and how far it feeds back in. I'll come back when this is really near the end here. I'm just printing out this. This is for my plastic shredder. Using a windscreen wiper. I've got a like metal bar that I'm going to fit onto the end of the shredder, and that should certainly grip in here. I've had an awful lot of problems with parts slipping in here, or unsure whether they're slipping and such like. Right, I'll come back. Now that just rewound there. And the wheel is turning there, so it's actually pushing the wheel backwards there. Well, it wasn't when it was doing the dual gear. Well, it was a bit, but it was tending the plastic, the filament, the retraction, I think. It was tending to like bulge up the plastic here. Anyway, I'll come back when this is just about to run out, okay? And I've got the signal. You need to set it up on the LCD one. Let's see, LCD 12864. So you want configuration. Runout sensor, see on. If I press that, I'll turn it off. So I won't press that, obviously. Got to wait for a screen. So there's the settings if you want to see, just out of interest. 215 on the nozzle, 60 on the heat bed, 100% on the part cooling fan. Right, as I say, I'll come back when this is right near the end. Oh, here we are. You see that the filament's about to go in now. It takes a bit. It's got to get past the, well, in this case the bolt or centre there before the wheel stops turning. And then it's got a bit of a run on anyway, to make sure that run on is settable in Marlin. See the wheel's still turning, even though the filament has gone in at this end. I think it's clicked now because it's gone, slight click there because it's gone past, there we are, it's gone past the wheel, the sort of bolt in the centre of the cogwheel. Is it cogwheel? The hub bolt, I don't know, like the middle bolt, cogwheel type thing in the bolt. like a filament grip thing, and then on the other side it's got that big sort of skate bearing which I mentioned. See, that's stopped now when the light is stable, so it's been getting a signal that it's run out. It's the same as if it jams, it'll stop turning as well, obviously, if it gets jammed. So after a short while, what seems like an age, actually, I think this is also changeable in Marlin. See, there we go. So the nozzles is coming to a position where I tell it to go to in Marlin. I ask it to go here in case I want to clean any ooze off the nozzle. And then, as you see, it starts doing a withdrawal, but it's pulled out of this filament runout detector in this case. So it's actually pulling the filament back out this board and feeding mechanism I've got, and this Creality Ender 5 Plus. The amount it pulls out, the speed it pulls out, all these are pretty much changeable in Marlin. Get that in focus, so you might see that that is turning backwards. Let's try and get a bit better focus. There we are, I think. So that is withdrawn, pulling out, I think it's 500, 700 or something like that I asked for to pull out. So gradually it's pulling that out from the nozzle all the way from the board and the tube. And as you hear, turn this light off so we can see the message on the screen. If we can get this to back in focus, filament change, insert filament and press button to continue. Right, I'm going to, well, I might be able to do this. Can I do this one-handed? Yes, because of the amount I ask it to retract there. I can actually just yank that out a bit. Right, I'm trying to do this one-handed. So I've got another spool of filament here ready when I can find the end of it. And I'm going to strip, I've already cut that at a bit of an angle, the end of the filament. Just try and straighten that out a bit. Push that in. If it does get tight, I can, like, I'm going to have to put the camera down, but I'm just going to lift this lever up to slacken this off so I can thread this in a bit easier. There we are, threaded it up to here. Actually it was bent a bit, still bent a bit the filament, so I had to straighten it out. Now I'm going to feed it into here to somewhere past this junction, the board and sort of clip thing on this dual gear feeding mechanism I have. I'll come back when I've done that. There we are. I reckon I've fed it up to about here, give or take a bit. Right, I'm going to go back down here, going to press the button. So the temperature on the nozzle is dropping, it's down to 70 there. But it's going to reheat the nozzle. So we do get a cooling down of the nozzle. This is the old filament that's come out. See the end of that was in the hot end. Okay, so it's going to warm up the nozzle. Then it's going to feed the filament in up to the nozzle, give or take a bit. So I'll come back when that gets to about 200 or more, sorry, 210 say. So it's on 207, 208, and I'm just going to clean, it's like I say, why I get the nozzle to come over to the front. Right, I got this, what is it, it's like a golf for cleaning golf balls, like brass bristles. This is, you get quite a few for, I don't know, not too expensive. Right, Okay, it's asking me to press the button again. Turn this light off so you can read it a bit better. Press button to continue and it will start feeding. Filament load. And now you can hopefully see that the filament is loading. Again, the amount it loads by is set under Marlin. You can change that in Marlin. See how the light flashes there? As the gaps allow the infrared beam to go through the gaps, so to speak, and then it's broken by the other part of the encoder wheel. Oops, sorry, the camera seems to go out of focus if I try to zoom in too much. Now when it gets somewhere near, which again is settable in the Marlin, this will actually slow down. It's going pretty quick now, but it'll start to slow down, go to a different speed, again adjustable in Marlin. The two speeds, you have a sort of fast speed and a slow down speed basically as it gets closer to the hot end. So the filament now is feeding along the Bowden tube, which is going into this conduit here. You might just see the blue tube there. Oops. And eventually it might, depending how much I've pushed it in here, depends whether it will come out this hot end or not, but there's no worry there because you do get a page, which again is adjustable in Marlin, the amount of page, which you can press the button and it will feed a bit more filament until it does come out the hot end. Page more, see it's asking, actually some has come out the hot end. Well, I think I'll page a bit more here. Just a second, let me get this light on. I'm going to press the button to page more, wait for page, and I ask for, it's going really to the side, that's indicating a nozzle block. It's been printing alright. Partial nozzle block. Just page some more. Just make sure, try and get rid of that. There we go, that's better. Okay, I asked for, I think it's 50mm page to feed 50mm. That's what's done now, it'll feed 50 and then it'll stop. Let me pull this raggy end off here. Yep, I've lost my heat sock. I'm going to be working on my heat socks actually. Right, so now I'm going to continue, go on the LCD 128, press for continue, and it goes back to the position it was in when it ran out of filament, and it'll just start continue on printing from that position basically. Now obviously we do lose a bit of feed there. Well, I think we can set that in Marlin to a bit less. There we are, feeding. And getting a signal. And printing. I've got this set to 80% infill on this print because I want it really strong. It's for plastic shredder, to shred plastic, that is, using a windscreen wiper motor. That's what this will be doing. It's going to have a metal bar in there that threads onto the windscreen wiper motor shaft, and because the bar is so big, it'll spread like the energy, the torque so to speak, spread the power over the plastic a bit more, and it shouldn't slip. I've had about 3 or 4 of these where it's definitely been slipping. Different ideas I've tried. Right, enough of that. As you can see, that's working okay. So I would probably recommend this method over my twin gear intelligent runout detection unit I did. So I'll just continue on printing there unless it comes across obviously a jam or the filament runs out. The filament won't run out on this because fresh spool on it. Let's have a quick look, see how long I've got. So suggesting there 3 and 4 hours. We might as well 4 hours left, give or take a bit. Might as well say 4 hours by the time it cools down. 215 on the nozzle, 60 on the heat bed, and 100% on the fan, part fan for this PLA I'm using. Right, as you probably see, it's finished printing. I asked for trim, which comes off 0.1 distance there. So there's the, I'll let you have a look at the edges, because then you can see if you get that in the light as much as possible. So pour a hole in case I want to put pin through. If this works, I might want to drill a hole through the metal bar that I'm going to have in here. The metal bar has a hole in with a 8 by 1 millimeter pitch thread. That's 8 by 1. Quite often, like with threaded rods, these are threaded rods here. Well, there's one of them. That is the bed up and down. The other one's on the other side. They're 8 by 1.25, and that seems to be the more common size. So it's 8 by 1 millimeter. Can you see any? Slight bit of mark there. But there's no way I can pull that apart, I don't think. But that is adjustable, that time limit. I think I've gone a bit high there in Marlin. Yep, so that works alright. Oh, by the way, in case I can't remember if I said, I've had easy 20 prints while it's been had this system on. This one here, using the sort of idler bearing. I just see it's glistening through there, and it hasn't given any false readings. And some of those prints have been long prints, 12 hours, maybe even a bit more. Some have been shorter, but there's been at least 20, if not more, prints on this without any issues. So it hasn't given any false readings whatsoever. And the only time it's given a reading is when it should, when I showed you earlier that the filament was running out. So this is, I'll say, a bit adjustable, so I can tighten that down. Need to grip more, but it wants to be on quite as loose as you can, just to maybe tiny bit tighter, just to make sure in my opinion, so that it can, when it retracts, this will go backwards. Otherwise the pressure of this spring is going to, I think, make it so too much friction in a way to go backwards, and then it's going to bunch up here like a bridge. Right, so that's my new version of this intelligent filament runout detector.